Hey guys, this is your help video for Navigator session 16. We are decomposing, that means breaking apart the number 1 and kind of thinking about what decimals build up the number 1 or how many numbers can be put together to form the number 1. We are getting close to the end here, so this is one of the last Navigator sessions before we have our test, so make sure that you're reaching out with any questions that you have, okay? So we have our opening problem. It says, use the number line if you want to help you answer these questions, but we're going to come up with 2 decimals that would add to 1 whole. And they don't have to be the same number. So the obvious one that kind of comes to most kids' mind is to use 0.5, because I know 0.5 and another 0.5 would get me to 1 whole. But you don't have to use 0.5s. I could also do, let's say 0.3. And if I add 0.3 and 0.7, I would make 1 whole. So these numbers don't have to be the same thing. You just have to have 2 numbers that add up to 1, okay? And then you are going to next come up with 3 numbers. So 3 numbers that add to make 1 whole. Again, they don't have to be the same number. So if I use 0.1, and then I use another 0.1, you can repeat numbers, that's fine. I need 1 more number in order to get 1 whole. So 0.1 and 0.1 would be 0.2, and I know in 2 and 8 make 10, so a 0.2 and a 0.8 would make 1.0, and so the thing I'm missing would be a 0.8. And so those are 3 numbers as an option of things that would add to 1 whole. There's lots of choices. They don't have to be these, okay? You just need to have 3 numbers in here that add to make 1. Number 4, you're coming up with 4 numbers now. So each time we're adding on 1 more number, still breaking it apart to get to 1 whole. So let's say I did 0.2 plus another 0.2, I'm at 4, plus another 0.2, I'm at 6, and I get only 1 more number. And it would have to be 6 plus 4 would make 10, so that it would carry the 1 over to get 1 whole. So if I did 0.2, 0.2, 0.2, and 0.4, I'm making 10. The 0 goes here, right? I have a decimal, and the 1 gets carried over, so it comes in front of the decimal place, okay? And that would make the 1 whole. All right, so your next one, you need 5 numbers. So 5 decimal numbers that you would add together to make 1 whole. They do not need to be the same number, and yes, you can repeat numbers within there. So let's say I did 0.1, 0.2, 0.3. Let's see, what am I up to? So 3, 6. So let's add another 0.1, would make 7. I'm at 4 numbers. I get 1 more number until I get to 1 whole. So I have 6, 7, I'm at 0.7, plus that would have to be a 0.3 in order to get to 1 whole. Again, there's lots of options. You're just coming up with 5 numbers, 5 decimal numbers that you could use to add together to get to 1 whole. Okay, so that's for your opening problem. And then we get down to our work time problems here. And it's kind of similar. So now it says come up with 2 decimals, but this time they have to be the same exact number that you could add to make to 1. And that's not so bad when it's only 2 numbers, right? If it's 2 numbers, we know we could do 0.5 and 0.5. They're the same number, and they add to get us to 1 whole. So we know that one would work. But on number 7, we have to come up with 4 decimals, and they all have to be the same number to get you to 1 whole. And so I'm thinking about how can I really divide 1 by 4 so that I get the exact same number for each of these things. And so 4 can't fit into 1, so I add a 0, and I add a decimal, and I bring a 0 in. 4 fits into 10 twice. My decimal comes up. And that's 4 times 2 is 8, so I can subtract 8. 10 minus 8 is 2, and I'm going to bring in another 0, and continue dividing. 4 can fit into 20 5 times, which is 20, and I have no leftovers. And this makes a bit of sense because I'm getting something that looks like a quarter, right? 25 cents. And there's 1, 2, 3, 4 quarters that makes $1, right? So I know that if I add 0.25 4 times, so I'm using the same number 4 times, then I'm going to end up getting $1 because that's what quarters are worth. And I know 4 quarters are $1. One more here, and that would make 1 whole, okay? So the next one, you need to do the exact same thing, but with 5 numbers. So this time you could take 1 and divide it by 5 and figure out how many times 5 can fit into 1 whole. Well, it can't fit in, so we add a decimal and we bring in a 0. Hey, 5 fits into 10 nicely 2 times. So these are going to be not 0.25s, not 25, but these are 20s, right? 20 cents, 40, 60, 80, $1. So these would be adding by 20s. So you would have all these 0.2s added together, and you would have 5 of them. Again, these have to be the same number that's being added in order to get up to 1 whole. Okay, so this makes 1 whole. So could you do it with 10 numbers? All right, so you're going to think about what would be the number that I would divide, or what when I divide 10 in, how many times I guess would it fit in, and what would the decimals be that you would add together here? And then do you think that this pattern is ever going to end? Could I come up with 11 numbers? Could I come up with 20 numbers? Is there ever an end to what we're doing where we're breaking it up into more and more pieces? And the answer is no, right? I can always add another decimal, and here's why. For example, if I do 0.9 and 0.1, I'm already to 1 whole. But I could do 0.99 and 0.05 and another 0.05 to get there. I could not just have 1-digit decimal numbers, but I could have 2-digit or 3-digit or 100-digit decimal numbers. And I can always split these numbers up into smaller and smaller and smaller chunks. And so no, there's never going to be an end to this pattern. I can always add more decimal numbers together in order to get to 1 whole. So what does the smallest possible decimal that's bigger than 0 look like? And I don't think we can even write it. I know it would have the decimal. It has to be bigger than 0, so it can't be 0 point just 0, right? Because that's exactly 0. I know the smallest number I could put into this place would be a 0, but I could add lots of zeros, zeros. I could add so many zeros that I couldn't even continue writing them, and neither could a computer. And it's going to go on and on and on and on and on indefinitely, right? An infinite amount of zeros. But I know that this last digit at some point would probably be a 1, because in order to make this greater than 0, it'd have to have at least a 1 at the very end. But there would be so many zeros in here that we couldn't even count them. So an infinite amount of zeros in between where that decimal point is and where that 1 is. All right. And then what's the largest decimal number that's smaller than 1 whole? Well, that means it has to be really close to 1 whole. And so if it's a decimal that's really close to 1, it's going to start with 9s instead of zeros. But I can make that 0.9 bigger by adding another 9 and another 9 and another 9. And this is going to go on and on and on and on, right? An infinite amount of 9s. And eventually it would end still in a 9, but it's never going to end, right? I can always get a smaller and smaller chunk to get closer to 1 whole, but not touch it. And that's the idea of infinity. So you've seen this symbol and you've heard that word before. And that's what we're talking about with these things, that there's an infinite number of numbers between any two numbers. Between 0 and 1, there's an infinite number of numbers. Between 0.1 And point 2, there's an infinite number of numbers because I can always break into smaller and smaller pieces and chunks. Okay, so you have that reflection to finish out, and then make sure that you submit this. Remember that you can jump onto the Zoom session today, Wednesday, with any questions that you have. That's from 2 to 2:30. We've got a test coming up, so we're kind of at the end here. So make sure that you're reaching out with questions that you have so that you can get some help. All right, hope everybody's doing well. I'll talk to you soon.